TimberTech Buildings is a structural design software for analysis of timber shear wall structures, realized using both cross-laminated timber and platform frame systems. Starting from a three-dimensional graphical interface, TimberTech allows the user to easily define the timber structure from preloaded databases, to analyze and check it under static and seismic loads and, finally, to export the calculation report together with some drawings and the three-dimensional model in IFC format. The aim of this tutorial is to illustrate the main features of the software, giving a brief description for each of them. The window currently displayed is the software welcome page. On the right side you can see the latest updates released. Access the tutorial related to the main features of the program, as well as read the latest news related to the world of timber structures. On the left side you can create a new project. Open previously saved projects. Read the online help. Define the software settings and access the personal area from which you can change the settings of your license and download the user manuals. Software is available in several languages, both for the working interface and for the automatically generated outputs, among which we find the calculation report and the drawings. Languages currently available are English, Italian, Spanish and Greek. When you create a new project, the first information that is requested is the standard to be used. You can choose between the Italian technical standards of 2018 or 2008, and the Eurocodes with the national annexes of many European countries. For this tutorial we will use the Italian technical regulations, and specifically the ministerial decree of 17 January 2018. Subsequently the software asks to insert the position of the site of the building that we want to model. This operation can be performed in three different ways: by moving the cursor on the map, by means of drop-down menus, or by manually inserting the geographical coordinates and the altitude above sea level. In the next window the user has to enter the information necessary to complete the description of the building. This information will be used for the automatic printout of the calculation report. Proceeding, you reach the main windows of the software. The program, in fact, is divided into three parts. The Draw and View tabs belong to the first part. The software is integrated a three-dimensional CAD that allows you to insert the elements of the model, including walls, pillars, floors, and beams. In this phase the user will have to worry only about the geometric construction of the model, without considering the type of cross-sections, the materials and the other properties, that will be assigned in a second time. The second part refers to the tabs Define and Project Properties. In the first of these the user can define all the properties that characterize the structural elements, such as the type and characteristics of the walls, the characteristics of the floors, the cross-sections of the linear elements, the materials and the connections. Moreover, you can define all the properties necessary to perform the following checks: lateral buckling of the beams, floor vibrations and deformability of the elements. Finally, the third and last part allows the user to validate the model, launch the analysis, read the results and check the verification status of the structural elements. Additional functions can be accessed using the buttons at the top of the screen. Among these we find the possibility to save the current project, the undo and redo functions, a function that allows to search for an element within the project, and the milestone function, which allows to create recovery points of the project with the possibility to recall them at any time. We can now proceed with the description of the first tab. At the top of the screen is the menu with the buttons to access the various drawing functions. The insertion of the various parts of the structure is done by means of objects. Among these there are the walls, which are grouped into two main types: the simple wall that can be defined by two base nodes and the height, and the polygonal wall that must be defined by the vertices of its perimeter. The methods for inserting the other elements are just as simple. For the column, for example, the base node and the height must be inserted. As regards the beams, the two end nodes must be defined. For the floors and the roofs, the user has to define the nodes on their perimeter. There are also tools to support the designer in the drawing phase, such as lines, points and grids. These tools are very useful in the geometric construction of the models, as they allow to define nodes to snap to during the geometrical definition of the structural elements. Grids, for example, consist of a set of evenly spaced nodes which facilitate the insertion of vertical elements in buildings with a regular plan. In addition to the commands illustrated so far, we find a series of functions typical of the CAD software. Among these there are the copy function and the mirror function. The most convenient way to define the geometry is certainly the one that uses a drawing as a modeling guide. The drawings can be loaded by means of DXF files. The software allows you to load files containing both two-dimensional and three-dimensional drawings. The latter are widely used for the geometrical definition of the roofs, in particular those with very complex shape. As regards the work area, please note that this is divided into 3 zones. In the main area it is possible to view the three-dimensional model of the structure. In the bottom window you can read the history of the commands used so far, as well as information and messages related to the functions being used. The command line is situated in this window and it allows user to call up commands by typing the corresponding name. In the right part of the screen we can then find the Properties menu. This becomes active every time you select an object in the 3D model. Let's proceed with the construction of the geometric model of a simple residential building. Thanks to the previously imported reference lines, the walls can be defined by clicking the left mouse button on the start point and on the end point of each segment. We can then proceed with the insertion of the columns, of the beams, and of the floors. Once the floor geometry has been defined, it is possible to edit its direction simply by changing the angle in Properties menu. In this menu you can find and modify all the other properties attributed to the selected structural element. It is worth noting how, in the insertion of the geometry, it is possible to define the static scheme of the elements subject to bending moment, including beams and floors. For example, for a joist's floor the software automatically recognizes the supports positions from the walls and the beams that support it. If, for each rafter, you want to get the static scheme of a beam on 3 supports and 2 spans, you will have to draw a single area of slab, continuous above the central support elements. If, instead, you want to get simply supported joists, you have to draw 2 different areas of floor, one for each span, interrupting their continuity in proximity of the central support elements. We can now proceed with the insertion of the walls of the first floor. The insertion methods are the same used for the walls of the ground floor. Let's finish the geometric construction of the structure by defining the roofs. Note how this operation is particularly facilitated thanks to the presence of the reference lines. We had previously defined the walls of the first floor as simple, and therefore they have top edge that is horizontal. At this point we must modify them so that they adapt to the shape of the roof. Very useful for this purpose is a function that allows you to automatically extend the wall elements. By means of the View filter, you can deactivate the view of the floors in order to make the selection of the walls easier. We can then proceed with the extension of the walls, to ensure that their top edge will adapt itself to the shape of the roof. Let's proceed with the second tab, the View tab. In this windows you can choose how to display the model. It is possible to set the zoom. Moreover, you can set the point of view of the 3D model. Here you can also activate the extruded view of the model. This display mode is very useful to get the graphical representation of the overall dimensions of the structural elements and therefore find any errors related to the geometry. As will be shown later, you can assign to each element some properties. These are shown in the right menu. For a quick check of the assignments, it is possible to use the function color by properties. This function, in fact, returns a graphical representation, in the global model, of the properties of each element. For example, you can view the type of connection associated with each wall. Each color corresponds to a different type. You can also view the type of load associated with the different floors. Also, in this case, different colors represent different types of load. Up until now we have shown how to construct the geometric model of the structure. We can now proceed describing how we can define the properties of the elements. To do this, it is necessary to use the tab Define, in which it is possible to edit the properties that the software assigns by default to the elements, and create new ones congruently with the geometry, the materials, and the connections of the real structure. The operations used to define the properties of the materials and of the connections are facilitated thanks to the presence of very extensive archives, in which all the properties necessary for the analysis and the static checks are preloaded. The archives can be opened by clicking with the mouse on the corresponding buttons at the top of the screen. Among these is the Wood Materials Archive, composed of the following tabs: Homogeneous and Combined Glulam, Softwood, Hardwood, and Duo, Trio beams. For each material different strength classes are available, and for each of them the mechanical properties are listed. Then there is the archive of the panels, usually used as bracing elements in the framed walls. Here there are plywood panels, OSB, particle boards, LVL, SWP, and gypsum fiber boards. Among the archives of the wooden materials we can also find that of the CLT panels. This archive shows the products of the major European CLT suppliers. The properties included in the software have been taken from the certificates of each product. To attribute the properties of a specific panel to a CLT element, simply select the desired product from the list. As regards the cylindrical shank metal fasteners, the software provides the user with a vast archive containing most of the connectors on the market. Many other will be added. Among these we find smooth nails, threaded nails, nails for plates, staples, screws, fully threaded screws, and screws for plates. To complete the joints there is also the archive of connection elements. In this are preloaded the properties of the hold-downs, of the timber to concrete tensile plate, of the double hold-downs, and of the timber-to-timber tensile plate. Regarding the shear connections, there are the timber-to-concrete angle brackets, the timber-to-concrete shear plates, the timber-to-timber angle brackets, and the timber-to-timber nailed plates. For each type of connection are listed the main products on the market. With the software you can calculate and check linear steel elements. Also for these, in the archives, the properties of many cross-sections are preloaded. In the central part of the top menu there are the buttons for defining the properties of all the types of elements present in the software. Using the Wall Type button it is possible to see the list of all the types of walls previously created. Within the same project you can create and use several types of wall, also different one each other. The creation or the modification of a specific type of wall can be carried out by means of a series of self-explanatory windows that can be recalled from different points in the software. Concerning the CLT walls, you can decide if the wall is monolithic or jointed. You can define the stratigraphy of the panel by simply clicking on the corresponding row of the archive. You can decide the basic material to use for the boards. You can also decide the direction of the boards of the outer layers of the panel. Starting by this data, the software will automatically calculate the effective Jeff shear modulus. Note that this parameter is editable by the user. This feature can be useful to insert the properties of a material not present among those in the archive. In the case of a segmented wall, and therefore composed of several panels joined together, the following tab allow to define the properties of the sub-panels. Specifically, the length of each one. Once this definition has been applied to a geometric wall element, the software is able to automatically recognize the number of subpanels in the wall. In the 3D geometric model you will not have to draw all the subpanels, but a single geometric wall element, to which you will have to assign the newly created definition. As regards the types of joints available, there are joints with inclined screws, half-lap joints, joints with butt strap boards, double butt strap boards, and joints with central board. Using the last tab you can then define all the properties of the joint, among which are the material of the board, the thickness of the board, the type of connector to be used, which can be loaded from the archives. You can then define if the connection is pre-drilled or not pre-drilled and the fastener's spacing. The software uses all this data for the automatic calculation of the resistance and stiffness of the single connector. The same data will then be used to calculate the overall strength and stiffness of each vertical joint. Note how it is possible to manually edit the strength and the stiffness value of the fastener. The user therefore has the maximum freedom and can, for example, insert the properties of a connector that are not among those in the archive. The method of defining the framed walls is quite similar to the CLT walls. The name of the typology must be defined. If the bracing panel is present on one or both sides of the wall, and if the sides are equal each other or different. It is also possible to define the strength class of the timber to be used as well as the geometric dimensions of the elements that make up the frame. The following tab allow the user to define the properties of the sheeting boards in terms of material, thickness, and width. They also allow to define the type of connection between the panel and the frame. Let's proceed with the dialog windows that allows you to define the characteristics of the floors. The user can choose between three types of floors. The first is that of the joists floors. In the corresponding window you can define the type of wood as well as the geometrical properties of the cross-section. Then there are the solid wood floors. Here you can define the material and the geometrical properties of the section. The last type of floor is that of the CLT floors. You can load the panel stratigraphy, read the panel characteristics, rotate the direction of the outer layers, and display the element properties automatically calculated by the software. The definition of the properties related to the cross-sections of the linear elements is very intuitive, and will therefore be presented here shortly. For the timber cross-sections, the material, as well as the dimensions, must be defined. For the steel sections, the type of profile and the class of steel must be defined. On the basis of the choices made by the user, the software automatically calculates all the inertial properties of the section, in order to perform the relevant checks. We can now proceed with the description of how to create and manage the wall connections. The correct mechanical characterization of them is of fundamental importance, since the dynamic behavior of the timber shear wall structures is largely influenced by the presence of the connection elements. The software provides the user with very fast and powerful tools for defining the mechanical properties of the connections, both for their strength and for their stiffness. The first information that is required when defining a connection is its position. Specifically, the connections are divided into two groups: ground connection and upper-level connections. In the next tab you can define the types of connections to use. There are two main types of connections in the software: connections for tensile forces, that constrain the rocking mechanism of the wall, and the connections for shear forces that instead constrain the rigid translation of the wall. Among the traction connections are hold-downs, timber to concrete tensile plate. On the other hand, among the shear connections are the angle brackets with anchors, the angle brackets on bottom timber beam, the timber to concrete shear plate, and the timber to timber shear plate on base beam. Thanks to a series of windows, the user is guided in the operation of mechanical characterization of the connections. Specifically, you can choose the desired type of angle bracket, between those in the archives. Once the choice has been made, the software will automatically load all the data necessary for performing the analyses. For tensile connections, such as this hold-down, the user can choose the number of connections to use for each wall end. The window shows the strengths of the different failure mechanisms that may affect the connection. For hold-downs, for example, there are the strength of the nail connection, the strength of the material of the angle bracket, and the strengths of the anchor used in the steel to concrete connection. The software also calculates the stiffness of the connection considering the deformability of all the elements that compose it. It's worth noting that the value of each property can also be manually edited by the user, by overwriting the automatically calculated values. This feature is very useful to insert data related to connections that are not present in the databases. Among the properties that can be edited by the user are those related to the lateral buckling of timber and steel beams. You can choose the load application point and the presence of lateral restraints at the top and at the bottom of the beam. For timber floors, the global dynamic behavior is a very important dimensioning criterion. For this reason, the software also performs vibration checks of the floors. All the necessary parameters can be set in the appropriate window. These include the required performance levels, normal or high, the damping value, and the stiffness of the non-structural transversal layers. For the check, the software uses different criteria depending on the fundamental frequency of the floor. Please note that the software is able to carry out the checks also for floors that have a fundamental frequency lower than 8 Hz. Among the serviceability limit state checks there are the structural elements deflection checks. You can define different limiting values for each element present in the model. Loads acting on structures can be defined very quickly thanks to the interface that is very clear. In the dialog window you can enter the name of the load and its position, specifically if it is a roof load or an internal load. You can also define the type of load and the intensity values associated with the definition that you are creating. Note that if you choose the Italian standards, the intensity of the loads is calculated automatically. You can however modify the values as you wish. Up to here it was shown how to build the geometric model of the structure and how to create and modify the definitions of the materials, of the cross-sections, and of the connections. The next step concerns the association of a specific definition to a geometric element. To do this, just select an element and use the drop-down menu on the right of the screen to choose one of the previously created definitions concerning the properties that you want to modify. Now, let's talk about the Project Properties tab. Here you can modify the position of the site of the structure following the procedures previously described. You can also edit the properties for the calculation of the seismic action. The first choice concerns the origin of the spectra. In particular, these can be calculated automatically by the software, or loaded by the user in the form of numerical tables. If you opt for the automatic calculation of the spectra, you will have to define a series of parameters related to the type of construction, the characteristics of the ground, and the topography. The elastic response spectra will then be reported by the software in a specific window. For the definition of the project spectra, additional properties must be defined, including the regularity in elevation, the ductility class, and the structural type. On the basis of the choices made, the software will propose an adequate structure factor which in any case the user can modify. In the same window you can then define all the parameters, as proposed by the technical standards, for the calculation of snow and wind actions. You can also access the project settings. Here you can modify the standard used in the analysis and view all the coefficients used in the checks. You can define the limiting values for the interstory drift checks and the factor used for the verification of shear resistance of members in bending. In the settings you can then modify a series of specific parameters related to the calculation of different types of elements, among which there is the CLT. The user can choose the calculation model to use for out-of-plane actions and for in-plane actions. Other settings concern the calculation of the load-bearing capacity of metal fasteners and the calculation of the framed walls. There are also settings regarding the vibrations checks of the floors and regarding the auto project of the connections of the walls. Let's analyze the third and last part of the software. In this tab it is possible to validate the model, to launch the analysis, and to read the results. Let's analyze the third and last part of the software. In this tab it is possible to validate the model, to launch the analysis, and to read the results. Specifically, checks are carried out about the assignments and the compliance with the indications provided by the standards. There are three main types of error messages. The first type is indicated by the red coloring of the elements. In this case the user's intervention is required in order to correct the model. In any case, the user is guided with precise indications regarding the type of error and the operations to be carried out to solve it. In the case in hand, for example, the software reports an error concerning the connection assigned to the wall on the ground floor. Specifically, an interfloor connection has been assigned to this wall. To solve, you will have to go back to the previous tabs and change the type of connection. A second type of error message is that related to the orange color of the elements, like those shown here. In this case, the user can decide to manually solve the problems or let the software makes the necessary changes to solve them, in order to launch the analysis. Note that all the automatically applied changes are listed at the bottom of the screen. In this way, the user always has complete control over the design process. The third and last type of error is that related to the information messages that color the elements in blue or light blue. Unlike other types of messages, the presence of one of these messages does not block the analysis. The messages have, in fact, been designed as a tool to support the designer, in order to identify possible inaccuracies within the model. Once the whole model has been validated, it is possible to proceed with the analysis. The user can decide whether to launch only the analysis for vertical loads and wind, or to launch the seismic analyzers too. The types of analyzers available are equivalent static analysis and the multi-modal response spectrum analysis. They can be launched at the same time. In the Validate and Calculate tab, there is also the button to launch the auto design of the wall connections. This function makes it possible to find the optimal number of tensile and shear connections to be used in each wall on the basis of agent forces. We can therefore launch the analysis. Once the calculation is completed, additional tabs are activated, that allow you to read the results in terms of internal stress, and verification status. The results can be investigated using the two drop-down menus on the left, at the top of the screen. With the first menu you can choose the group of combinations you are interested in, while with the second, you can view all the combinations that the software generates automatically, displaying, at the same time, the coefficients applied to the loads. For example, observe the load combinations at the ultimate limit state, or the combinations for the limit state for the safeguard of human life, that include the seismic loads. The stresses present inside the structural elements can be recalled and represented on the screen, by means of the buttons, that are located at the top in the central part of the menu. There is a button for each type of element: wall, column, floor, and beam. Below each button there is a drop-down menu, that allows you to choose what to display, the stresses, bending moment and shear force, or the displacements. These quantities are displayed by means of contour plots in the 3D model. There are mainly three ways to read the stresses and the verification status of the elements. A first way is the graphic one using the color bands directly in the 3D model. A second way is to use the tables located under the 3D model. The data are summarized in numeric format. It is also possible to select any element and read the same data in extended format, in the menu on the right. For the beams and the floors you can also use the Details button located on the right side of the screen. This one allows you to display the static scheme, and the intensity of the applied loads, evaluated for the selected combination, as well as the diagrams of the stresses of the bending moment and of the shear force. For the load combination at the serviceability limit state, you can also display the deformations of all these elements. The verification status of the elements can be recalled by means of specific buttons, one for each type of element. The representation of the verification status is done by different modes. The first mode involves the use of the indicators present near the previously mentioned buttons. The green tick indicates that all elements of that type, for the considered combination, are verified. On the other hand, the X on a red background indicates that some verification is not satisfied. Another way to represent the verification status is the graphical one. The elements for which the checks are all satisfied are green-colored, while those for which some checks are not satisfied are red-colored. Please note that the table below shows the demand-capacity ratios expressed as a percentage. Also in this case, they are associated with a graphical indicator for a quick identification of the elements that present some problems. The same symbology is also used in the drop-down menus, where, next to each load combination, or group of combinations, there is a graphical indicator to identify the verification status associated with that specific combination. The rows in the table below can be easily reordered in order to find the unverified elements. For example, let's assume that we want to find the walls in which the checks of the connections for tensile forces are not satisfied. To do this, simply click on the legend related to the checks of the tensile connections, and then select the row corresponding to one of the unverified walls. The selected wall will be highlighted in the model for easy identification. It should be noted now, that in the right menu all the checks associated with the selected wall are reported in detail, including those relating to the different failure mechanisms of the tensile connection. From the observation of these checks, it is clear that, in this specific case, the connection fails due to failure of the nailed connection. So, the number of nails can be increased to satisfy the checks. From the foregoing, we understand how, thanks to the tools provided by the software, it is very easy to identify and resolve any unverified elements. From the Analysis tab it is possible to open the menu related to the horizontal actions, in which all the information regarding the lateral loads are summarized, wind, and earthquake. For example, for the wind is given the coordinates of the points of application of the resultant forces at every level, and the total forces at the base of the structure acting in the two main directions. On the other hand, as regards the seismic actions, in the windows you can find the coordinates of the mass center of gravity for all the decks, with the relative accidental eccentricities and the translational and rotational masses. For the multimodal analysis, the data related to the different vibration modes are also reported, including the natural periods, the relative spectral accelerations, and the participation factors. Further down we find the resulting forces at the floors and the base total shear. In the next tab, Modal Analysis, it is possible to visualize the properties of the vibration modes, both numerically, by means of the respective drop-down menu, and graphically by means of the model. To better display the deformed modal shape you can also activate their animation. You can also export the main documents required for the structural projects. These include the calculation report and the drawings. It is also possible to export the model in IFC format, which allows the exchange of information with other software without loss or distortion of data. This file format is usually used in BIM. Let's export the technical calculation report. The report is exported in Microsoft Word format, and it is therefore totally editable by the user, who can, for example, add texts or other information. The report is structured to be easily readable. It does not only contain numerical data but also descriptions of the used calculation models, references to standards, formulas, and finally tables with the numerical data and the checks. The drawings are exported in DXF format and contain the plans of the structures for all levels. These drawings show the distribution of the walls and their connections, appropriately identified by graphic symbols and indications relative to the quantities. There is also a legend with a description of the symbolism used. It contains detailed information regarding the connections used in the project. The properties of all the structural elements are reported both in graphical form and in tables, which are very useful in the composition of the blueprints. Specifically, the plans contains the distribution of the beams and of the floors. The elevations of all the walls of the structure are represented too. Another very useful function is that which allows you to export the reactions at the base of the structure. The user can choose whether to export these reactions as concentrated forces, in the central node located at the base of the wall, or in several evenly spaced nodes along the wall. In the dialog box, you can also choose the units of measurement, to be used in the exported files, and the load combinations to be exported. When you export, the software generates data both in numeric format and in graphic format that can be loaded into other software. Further information can be found on the website www.timbertech.it.